All right, class, good afternoon. So what we're going to look at is the transformations of the absolute value function again, okay, multiple representations. And this time we're going to do several transformations at the same time. So let's review some domain and range here. And then maybe even all the transformations. So it's basically just going to be some examples, and let's just go on from here. So let's look at the first one. So they give us the equation, or they give us a description or graph, and we'll just come up with the other way to do it. So in this one, they give us the equation, the absolute value of x minus 4, which means this is going to move down 4 units, okay, because it's negative, k value is negative. So we also want to remember our general absolute value transformation function. So x minus h plus k on the outside. So remember, k moves it up and down, and that's what negative 4 is here. It's our k value. All right, so basically all I'm going to do, since I just got a blank grid here, I'm just going to put vortex 3, 4 there, and just roughly draw the absolute value function. Keep in mind that you have to have in mind our parent function is always etched in our head. So if you want to draw it there, you can. All right, let's go ahead and I'll go ahead and put the parent function. Hopefully it doesn't get in the way. Okay, so let's look at the domain and range here. So in this one, it's going to be all real numbers as far as going left to right on the x-axis. As far as the range, see how it moved down 4. So basically it's going to start at negative 4, and then it goes up to infinity, parentheses. All right, generally, just work these things left to right. So here we have negative absolute value of x plus 3. All right, so we've got this negative here and our h here. So remember, it's opposite of the finished product. It's a negative 3. Okay, so if you remember your absolute value function, x minus negative 3, that double negative there, this is what's going to make it positive. Okay, so remember, h is negative 3. That means it moves to the left. So I'm going to go left 3 units, 1, 2, 3. There's the vertex, and it's going to open downward because it reflected by the negative. So reflects on the x-axis, and then it moves left 3. Okay, and that's what we drew here. As far as domain and range, still all numbers. And this time, remember, range is bottom to top, so this is going to be negative infinity to 0 bracket. All right, so this one here, so that one had 2 transformations. This one here has 1, so it's a 3 before the absolute value of x. So this can be a vertical stretch because it's greater than 1. All right, and since you don't have any grid marks, so I'm going to trace my parent function. It looks like that. And if it's a vertical stretch, it's going to be pulled vertically, which means I'll have a much narrower opening. And I'm just going to kind of exaggerate it, but there you go. It shows that it's been stretched. All right, so all real numbers for the domain, and the range would be 0 to infinity. All right. All right, 2 transformations here. Okay, so again, inside here, this is h, this is our k. So h here is going to equal a positive 1. So remember, it's opposite. K here will equal negative 2. K stay the same. All right, so this one is a plus 1, so it's going to right 1 unit. And then we're going to move down 2 units since it's a negative 2. So I'm going to make 1 tick mark to the right, 2 tick marks down, and right there will be my vertex, and it will open out like this. Okay, so remember, parent function is like this. So this shows it moving over 1 and down 2. All right, domain is still all real numbers, and as far as the range is now moved down 2, so it's going to be negative 2, and it still opens up to infinity like that. Okay, this one too. All right, so again, it's good to write your h and k's for this. So we got plus 2 inside, plus 4 outside, h, k, k. So h here is really a negative 2, and of course k is a positive 4. All right, so negative 2 means it's going to move left, 1, 2, and then up 4, 1, 2, 3, 4, and that's where our vertex will be. All right, so left 2 units, and then up 4. All right, so it's going to open upward like this. Again, big shift from where our parent function is. All right, so still opens left and right to all the numbers. And then as far as our range now, it is now starting 1, 2, 3, 4 up there. So it's going to be 4 to infinity. Okay, let's look at this one. So here we got negative in front, so it's going to reflect the x-axis. Better x's there. And then we have a k-value of 2, so up 2. All right, so 2 tick marks. And then since it's going to reflect, it's going to open downward like so. All right, parent function for reference. Right. Okay, so let's do domain and range. Still going to be all real numbers. And then as far as our range this time, again, bottom to top. So let's start at negative infinity and then climb up the ladder all the way to 2 bracket. Better infinity there. Okay, now we got description. So here it's telling us vertical stretch of 5 and shifts down 1 unit. Okay, so reference parent function. Okay, so a vertical stretch is going to be thinner and it moves down 1 unit. So 1 tick mark, vertex will be here, and then I'm going to draw it much thinner than that one. So that's the vertical stretch and moving down. So when you're doing your function here, okay, so we're going to have of x equals, since it's a vertical stretch, the 5 goes in front of the bar. Okay, it shifts down, which means there's no h unit, so we just have absolute value of x. And then we're going to put -1 for it shifting down. All right. Okay, so domain, still all real numbers. And as far as the range, starting at -1 to infinity, just like so. All right, this one, shift left 4 units, okay, and reflects over the x-axis. So there we go. We have a reflection, so start off with a negative, no stretch or compression. And since it's moving left, that means that's the h, which is inside the value. So x, so if it goes left, that is a -4. But remember, it's going to change values, so we're going to put +4. Okay, so again, from your transformation function, it would look something like negative absolute value of x minus a -4 because it moves left, right? Because here h is -4. So again, these double negatives make that positive right there. Okay, so let's put our reference function. Okay, so we're going to reflect downward and it's going to move left 4. So 1, 2, 3, 4, vertex and downward. All right, so all our numbers for the domain, left and right, but up and down, starts from negative infinity all the way up to 0 bracket. Okay, it shifts right to, see, again, we have another thing here where h is a +2. Okay, it's going to shift right, so that's going to go inside the absolute value bars. Units and shifts up 5 units, and this would be our k. Okay, so when we make this function, all right, no reflection, no stretch or compression, so absolute value x. All right, so it's going to shift 2 units to the right. We need to put -2, and then 5 units up plus 5 outside. So again, x minus, here we put +2 in there, the parentheses, and again, because negative times a positive makes a negative, that's why it's a negative there. So you kind of got to go opposite when you look at the left and right movement. One, you're writing your equation only. Okay, reference function, let's keep it red. All right, so parent function. Okay, so this one is shift right 2, 1, 2, and up 5 units. 1, 2, 3, 4, and 5. All right, so vertex is there, and it's going to go off this way. Okay, so domain still all real numbers, and then as far as the range, we're starting at 5 to infinity. Okay. All right, this one shifts down 3, okay, and reflects over the x-axis. So f of x equals negative. There's no left-right movement, so it's just h, and then down 3 is a negative 3 outside of the absolute value bars. All right. So reference, okay, and then we're going to shift it down 3. I'm sorry, right, down 3. So 1, 2, and 3. There's our vertex, and it's reflected downward, just like so. So all real numbers again for the domain, and then the range will be negative infinity, okay, bottom to top, all the way to negative 3 bracket. All right, so here we are, another description. Now this one has all 4 of them. Shift down 5, shift left 3, reflect over the x-axis, and the vertical stretch of 4. So let's go ahead. Let's work left to right. Hopefully I can fit it all in here. All right, let's see this. So f of x, do this. I'm gonna write f of x outside this box just so I have room. F of x equals. All right, so we have a reflection over the x-axis, a negative. So vertical stretch is the next thing by 4. So 4, absolute value bar. It shifts left 3 units. So that means we're going to have to put x plus, okay? Because here h equals negative 3. Okay, here k equals 5. So remember, we're shifting it the opposite sign. Okay, and then shifts down 5. So minus 5 here. So that should have been a negative 5 over there. Okay. So there we go. We got all of them in there. So let's represent that. Let's put our reference parent function here. Okay, so it's going to reflect down. It's going to be a vertical stretch. It's going to go left 3, 1, 2, 3, and then down 5, 1, 2, 3, 4, and 5. So right about there, open downward. Kind of do a thinner one because it's going to be stretched. Right, there we go. And that would be a good drawing of it. Okay, so all row numbers for the x-axis because it still opens out wide in left-right direction. And then for our range, bottom to top, negative infinity to negative 5. All right, there it is. Okay, all right, next one. All right, so shifts up 3. Okay, so this is k equals a positive 3. Shifts right 2. So h here equals 2. And then reflects over the x-axis, that's negative, and then a vertical compression of 1/3. Okay, so let's get this put in our function. So f of x equals, all right, so we have a reflection, negative of 1/3, absolute value bar. We have a left-right horizontal movement, so we have x inside the bars. So since it shifts right 2, we got to put in negative 2 inside. All right, signs change again. All right, outside sign does not change. It's going to go up 3, so plus 3. Okay, so reference parent function. Okay, so we're going to go right 2, 1, 2, up 3, 1, 2, and 3, reflected, and a vertical compression. So I want to make this much wider than parent function. Opens downward just like that. So all row numbers for the domain, and for the range, again, negative infinity all the way up to positive 3 there. Alrighty, guys. So that is your transformations. I kind of feel like I want to explain these bottom ones just really quick because of the inside. So your transformation formula for absolute value. Okay, and what I'm trying to show here is why this keeps changing signs. So if I put all the values in into the function, so we have our negative, our a is a 4, x minus, but the h here is going to be a negative 3, right? And then minus 5. Okay, Sorry, I put plus 5 here. It's supposed to be plus k. Okay, because 5 is our k there. Our negative 5 is our k there. So, again, right here, guys. Okay, because of that double negative, that's why it is positive. Okay, and it works the same way for the bottom one as well. All right, guys, I think hopefully I covered that enough. Give these things a try and have a great day.